Today we're going to be performing 4 fall arrest tests on this standard cable rail system. We'll be doing one test at the beginning with one shock absorbing lanyard and 220 pounds of dead weight to simulate one employee tied to the top cable with a 7-foot free fall attached to a 6-foot shock absorbing lanyard. The second test, we will hook 2 shock absorbing lanyards to 440 pounds of dead weight, simulating 2 employees falling at the center span at the same time. For the third test, we will again hook 2 6-foot shock absorbing lanyards to the bottom cable to simulate 2 employees tied off to the lower cable falling at the same time with 440 pounds of dead weight. For the fourth test, we will hook up a 4-foot shock absorbing lanyard to the top cable to simulate a 5-foot free fall with again the 220 pounds of dead weight. All of our tests will be on the same run. What we have here is a load cell indicator provided to us by UltraSafe. This cell will indicate how much force is put on this post and this cable. Right now, as this cable is set up, it's already initially hit with 500 pounds of force just under the standard tension of the cable. We're going to measure how much force we have with each impact, and we're going to take some measurements on the post to see if the post deflects. This is our load cell set up for test number 1, also provided to us by UltraSafe. Right now it's set up with 220 pounds of dead weight. That factors to about a 310-pound human, which most body harnesses are maxed out at. We will pull this yellow cord when it's time to drop it, which will release the quick release, and it'll drop the impact on the cable here. We are at the center of this span here. The total cable run is a little over 100 feet, but for our span from west corner to our east corner is about 144 inches. The overall length of our cable today is 100 feet, but we're going from post to post because that's where most of our load is going to be. This is one of our used shock absorbing lanyards. Let me give you some general information about most shock absorbing lanyards, in particular this model here. It started out as a 6-foot shock absorbing lanyard before deployment. What happens is in a fall arrest mode, it's subject to a load. When this reaches no more than 900 pounds, the stretching material, which is woven into the shock absorbing lanyard itself, starts to deploy. And will deploy until all of the energy is released to a maximum of 9 foot 6 inches. So there's 3 foot 6 inches of deployment within this shock absorbing lanyard. Today we demonstrated this particular shock absorbing lanyard, which was subject to a load of 220 pounds of dead weight, deployed 2 foot 6 inches. Pretty average. I wanted to point out that this is a different shock absorbing lanyard than the other 3 previous tests. This is a ripstop body harness. The deployment is in a bag and it's overlaid within the bag. And as the test weight is applied and it starts to rip out at no more than 900 pounds of force, what happens at this interwoven white strand here starts to peel away from itself. And it peels away until the energy is dispersed. This black strip is a safety factor that if the shock absorbing lanyard bottoms out and takes the last stitching out, then you have a safety factor which will hopefully stop you and keep ultimate failure from occurring. These are our shock absorbing lanyards. The one on my right is our first test. It started out as a 6-foot shock absorbing lanyard. At the end, after it was test dropped with 220 pounds of dead weight, a 7-foot free fall, it expanded to 8 foot 6 inches, giving us an expansion of 2 foot 6 inches of deployment. The load cell here shows us the max force at this moment. So it showed us 2,515 pounds with one shock absorbing lanyard to simulate one employee tied to the top cable. We showed no deflection in this post. We showed no deformation to the post. On our second test, we had 2 employees hooked to the top cable with 440 pounds of dead weight and a 7-foot free fall. Started out as 6-foot shock absorbing lanyards. They deployed to 8 feet, giving us 2-foot deployment.
3, 2, 1. That took some impact. Oh, 3,680 on.
We showed deformation in the top part of the post and to the weld location and to the interior kicker post. And we had some minor damage to the inside of the cable. We showed deformation to the inside of this corner post, again at the weld location. On our third test, our employees were hooked to the bottom cable with 440 pounds of dead weight at about an 8-foot free fall. They started out as 6-foot shock absorbing lanyards and deployed to 8'6", giving us 2'6" of deployment.
3, 2, 1. Exactly what it was supposed to do.
On our third test, we were tied to the lower cable, and we showed further deflection after the third test to the post. It deflected about a 1/4 inch out. On the third test, which was 2 employees tied to the lower cable, again with 440 pounds of dead weight, we showed major deflection in the center span of the post.
If you'll notice, we did get some deflection down at the bottom of the stanchion, right where it cuts into the concrete. This is pretty typical, and this is actually a good thing. This is what's helping take the load if the employees do fall. You can see that the weight was handled in all the other places.
In our fourth test, our shock absorbing lanyard started out at 4 feet and deployed to 7'6" long, and it was attached to the top rail with 220 pounds of dead weight.
3, 2, 1.
On the fourth test, we showed no further deformation, which was our single employee again tied to the top cable. There was no increase in the deformation to the post. On the fourth test, which was again our single employee to 220 pounds of dead weight at a 7-foot free fall, we showed no further deformation to the top post.